Hello everyone. This video will show how to find the inverse of a given square root function and specify the inverse with its appropriate domain restriction. Now let's go over this example right here. To find the inverse of every function, the first step is to change f of x to y. So I'm going to go ahead and rewrite that down here. The second step is to change y to x and x to y. So I'm going to go ahead and rewrite that down here. The next step is to isolate y by itself. So in this problem right here, we want to have y on the right side by itself. So I'm going to go ahead and subtract 4 from both sides. Since I want y by itself, I'm going to go ahead and square both sides so I can cancel this square root. I want y by itself, so I'm going to go ahead and multiply 3 to both sides. So we want y by itself, so I'm going to go ahead and subtract 1 from both sides. Looking at this, our vertex is located at, so h and k, this is positive 4 and negative 1. So the vertex is located on 4, negative 1. We can therefore say that our inverse for this function would be f negative 1 of x is equal to this equation that we have right here. Now let's sketch the graph of the given function and its inverse. Looking at the graph, the function and its inverse is not symmetric with respect to the line of symmetry y equals x, which means that we are going to restrict this equation right here so that they are going to be symmetric to each other. To do that, we are going to look at the sign before the square root here, which is negative. So if we have negative, our restriction would be x is less than equal. So again, if it's a negative, it's going to be x less than or equal. And then next to which will be the h, which is 4. So this is the restricted domain. Now let's sketch this graph. If you notice, both the graph of the function and its inverse are symmetric already with respect to the line of symmetry y equals x. So this is the restricted inverse of this function that we have up there. Now let's have another example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over this problem here. So we are going to find the inverse for this. So I'm going to go ahead and show the work down here. Looking at this equation that we have right here, we remember that our vertex, so looking at this, our vertex is located on negative 3, 5. This tells us that our inverse for this function would be f negative 1 of x is equal to this one right here. We are going to restrict this quadratic function that we have right here such that both the function and its inverse are symmetric along the y equals x. In order that we can restrict this, we're going to look at the sign before the square root. That's a positive. Since it's a positive sign, our restriction would be x is greater than equal. So again, whenever it's positive before the square root, it's going to be x greater than equal. And the value that we have to put next here is the h, which is negative 3. Again, please remember that it has to be the h. So if we sketch the graph of both the function and its restricted inverse, we can see that both graphs are symmetric with respect to y equals x line. So that is how we find the inverse of a square root function and how to specify its inverse to its appropriate domain restriction.